Okay, everyone. So, hello, I'm Brendon, and today I'm going to talk to you about computer vision. So, I'm going to introduce myself at first. So, I'm Brendon Bousaz. I'm from France. I'm a former electrical engineer. I specialize in security system when I was studying in France, and as soon as I graduated, I started working in a security system company in Switzerland, where I was mostly spending my days working with CCTV system for private banking in this kind of place. But one day I realized that I wanted to know more about the complex system I was installing. So I took the decision to quit my job and I moved in Australia, where I resumed my study in the IT field. This is where I had the opportunity to get the introduction about computer vision, what I'm going to talk about here today. And of course, if I'm here today, it's because I enrolled in Code Chrysalis 2 months ago in my quest of becoming a better software engineer. So, here it is. So, what we're going to talk about today. At first, I'm going to give you a very broad introduction about what is computer vision and what is the application that computer vision can do. And I'm going to give you kind of a broad overview about what is the field nowadays and where is it heading. And then I'm going to jump into a more technical side of my presentation. I'm going to walk you through very simple image processing techniques that have been used for decades and are still used today. And then I'm going to go in the convolutional neural network. So luckily, my mate here, Charles, already kind of introduced you about this concept. So hopefully it's going to just be a review for you. And on the end, I'm going to try to explain a bit the latest state-of-the-art algorithm for object classification, the Yolo Algorithm, and I'm going to try to show you a quick live demo on my computer, trying to classify some object. So, I like to start most of my talk with a very simple definition. So there is many different definitions of computer vision. If I have to summarize probably all of them, they are all kind of emphasize the fact that computer vision just try to give the same ability to computers that we have with our eyes and our brain. So we try to make the computer understand the world around us the same way that we are doing it. So I believe that there is 4 different steps for computer vision. The first one will be acquiring, then processing, analyzing, and on the end will be understanding what is the picture talking about. So there is many different kind of science involved in computer vision. Of course, we have machine learning section, which is a hot topic nowadays. But of course, there is also physics because the optics are involved. We have neurobiology because most of the complex machine learning systems try to mimic the way brain are seeing and interpreting things. So I listed just down there some of the probably most famous applications that computer vision can have in the world around us. And it's just like a very simple list. There is a huge list we can build with plenty of different applications. But what is funny to see is actually if we look at this, most of these fields are actually applied in many different sectors of the economy. It can go from military, of course, autonomous driving, medical imagery, retailing, real estate, all this kind of sector of the economy are using some kind of computer vision techniques in their business. So, to explain you a bit how essential computer vision is nowadays, I wrote here some numbers. So the first one we talk about social media, and we have every minute more than 400 hours of video uploaded on YouTube, more than 200,000 pictures uploaded on Instagram and Facebook. And by some way, all this big company has to process this data. They all have to know what is inside these pictures. They need to know because they have to be sure that this is safe content. They also have to know what the data is talking about in order to sell you some advertisement, trying to target the right people on the right video or right picture. So this is one of the cases of computer vision. Another one, it's a very hot trend for the past few years, is the race for autonomous driving vehicle. The money is flowing from everywhere in this area. I don't think there is any big car manufacturer in the world who don't have some sort of autonomous driving program. And of course, yeah, the investment are huge in this area. No later than 2 months ago or 3 months ago, SoftBank again then invested more than 2 billion in the General Motors program. Money is really flowing in this area. So what is the problem of computer vision exactly? So if I ask you, like the same way Charles asked you, if I ask you what is this picture, of course you're going to tell me it's a cat, it's black and white, it's walking on the grass. It's very easy for us to analyze this picture. It doesn't take any, we don't have to think twice. It's automatic for us and it's coming very easily. It's like, it's something that we feel like we're born with. But now, if we put ourselves in the way that computer are seeing picture, what does the computer see? The only thing it's going to see is just a bunch of array with numbers on them. Here we have 3 arrays because it's a color picture. We have 1 array for red, 1 for the green, 1 for the blue, and that's pretty much it. So if we put ourselves in the position of the computer and we try to understand what this number means, we're not able to understand that there is a cat on this picture. So this is the whole challenge of the field, actually, trying to make computers understand the way we see things. So, not surprisingly, researchers try to understand at first how a human brain is working to see things. So, of course, most of us would think about when we see things, everything is happening in the eyes, but the eyes is just the tip of the iceberg. The eyes is pretty much just a sensor like a camera is. All the processing powers is going inside our brain. This is where the vision actually happens. And studies show that it's more than half of the brain that is involved in the visual perception of the things. So it's a very complex thing that involved a lot of different mechanisms in the brain. So this is what the latest research tried to mimic to make a smart computer vision system. So to try to make you realize how far the computer vision system have been so far, we try to just compare with the human evolution. And so when we think about the latest algorithm nowadays, we believe that the computer vision can do no better than a 3-year-old kid. So when I show a 3-year-old kid the picture I just showed you, like with a cat on it, it automatically will understand and tell you it's a cat on it. And this is something that we feel that this visual perception is kind of granted for us, but it's actually something very hard to master. That's why so far the best algorithm can match no better than a 3 or 4-year-old kid. So this researcher, very famous researcher in computer vision, trying to emphasize this by telling that understanding vision is actually trying to understand how intelligence is working. So from now, I'm going to try to explain you. I'm going to jump into a more practical section of my talk. I'm going to try to walk you through very basic image processing techniques. I believe these techniques are very useful and still very up to date nowadays. They are used to do some pre-processing. It's a pre-processing task to do before more complex things such as machine learning and image classification. So, in the case of edge detection, what is the purpose of this? Imagine we have just a simple picture, a color picture. When we do edge detection, we just try to keep the essential data of this picture. So, what the edge detector will try to do is it will try to understand, it will try to match the pixel, the sudden change of intensity in the pixel in the picture. And the output of this will simply be a picture with just the edge appearing. And this process can be used in many different areas where we don't need all this data. This is a heavy picture, this is a very light picture, but the meaning of the picture is still there. So there is many different kind of edge detector. I believe there's probably a dozen of them. One of the most famous is the Sobel operator, the one I choose to explain you and to walk you through the process of it. The process involved here is very interesting because even for convolutional neural network or other image processing techniques, the process and the technique used is pretty much the same for all of them. So imagine we have a simple picture. It's a black and white picture. It's very obvious for us. We have one edge. We have one side of the picture with darker than the other side. So we can clearly see there is an edge on the right on the middle of this picture. But the computer doesn't see this. We need to teach him. So what we're going to use for teaching the computer this, using the Sobel operator, we just need two filters. One filter will be in charge of just detecting vertical edge, the X filter, and the other one will be in charge of detecting Y filter. So how this is going to work? It's pretty simple. We're going to do some convolutional, like Charles explained a bit earlier. We're going to take the first filter, let's say the X filter, and we're going to just put it on the top left corner of the image. And we're going to do some very simple math using this filter. We're going to do some convolution. So what this will do is, for every pixel unit, we're going to multiply to the corresponding filter value. So the output of this will simply be quite long operation, but very simple mathematics. So it's going to be -1 times 100, 0 times 100, and we're going to do this, and the output of this will be a single number. This single number, we're going to store it inside the new array. So we're going to keep going like this. So we're going to do some convolution throughout all the pixels of the initial picture, and we're going to do again this. So in this case, we're going to do the next value, and this time the filter will detect an edge. So the value we have as the output will be different from 0. And we keep going on this. We're going to do this for the X filter and the Y filter. So the output of this will be two simple arrays. So what we have to do right now is just to try to combine these both arrays together. Even though in this case the Y gradient, the one who's in charge of detecting horizontal edge, didn't detect anything, in some cases we might have both detection on both arrays. So we have to do a simple mathematical operation just in order to combine them all together and be sure that the output of this is a positive number. So the final array will be this, and we are pretty much it. This is almost the end of the processing. We just need to decide the threshold. So in this case, if we want to be sure that it detects the edge, we just say like maybe all the value in this array over 150, they are white pixel, and all the other value are black pixel. So the output will simply be this. It's a very simple operation that we have to do for edge detection. And the output can be very valuable for further processing techniques. So now I'm going to try to walk you through another very interesting algorithm, the one used to do face detection. I'm talking about detection here, not recognition. This is the technique used before you do face recognition. You have at first, of course, to detect face. So there is face detection algorithm has been around for probably more than 50 years now, but for a long time it was very not accurate. Lots of false positive was coming out of this. And in 2001, two guys, Weil and Jones, came up with a very smart way to do face detection. This way is still very used nowadays to do in many of our systems. If you take a normal camera, you might see a red square surrounding the face of the people. This is most of the time the viral algorithm used. So of course after this time we had probably more accurate algorithm to do face detection, but viral algorithm is so efficient, it doesn't take so much processing power that it makes it still very used nowadays. That's why it's the one I decided to just explain you today. So like the previous one, it's everything. We're going to use some filters for the face detection. So what the filter will look for is for common pattern for every face. So these two guys, Val and Jones, just realize that if you look at the face, we can see some pattern in the face, some things that we can find in pretty much all the faces. So they kind of like decided a rule about this face, about this pattern that we can find in the face, and they kind of try to do some filter operation, filter detection, checking on different area of a picture to see if a face were present. So how they do this? They use 4 kind of filters, and they're gonna try to position this filter in a different in different areas of the picture in order to detect the face. So how this is working in an example. So we take a simple common face pattern. The first one that the Viola-Jones algorithm will look for. So we have this common face pattern that we know that the eyes region is supposed to be darker than the upper cheek. So we take this filter here, and we just place it, and we just place it throughout the image, and we just look for for light place surrounded by dark place. And if we have a match on this place, we just go to the next pattern. So this is a cascading way of doing this. So the next one would be, for instance, from the previous array you just checked. You go a little bit higher, and you check if there is a darker place on the top and a lighter place on the bottom. And if the check is good, we keep going like this, and we check many different patterns on the area we are checking. And if one is not good, the algorithm will just give up and keep going throughout the picture. But if we can reach the last common face pattern, so this means the algorithm detects successfully a face. And this is pretty much how the Viola-Jones algorithm is working. So now I'm going to try to walk you through the convolutional neural network. Luckily, Charles already kind of explained you roughly how things are working. So I'm going to try to give you the raw understanding for image classification problem. So at first, what is deep learning? What is a convolutional neural network? Like I told you in the beginning, these techniques are inspired from neurobiology. Some studies show that specific part of the brain, specific bunch of neurons are always triggered depending on the shape you are seeing in your vision. So it means like if you, for instance, if you watch a triangle, a very specific part of your brain will be fired always. And now if you change the shape to a square, it's another part of the brain will be triggered. And what the convolutional neural network tries to do is pretty much the same thing. It tries to trigger some specific filter depending on the shape you are watching or the shape you are scanning through the picture. So the convolutional neural network will focus on a very common pattern of the picture of the class object you're trying to classify. So why is it more efficient than others? It's not, the convolutional neural network is not sensitive to image distortion or probably dark image where shadow is very present in the picture. Or for instance, if you try to detect a cat who has a heart on his face. So in this case, the convolutional neural network will probably still detect the cat, even though it's not a convolutional common cat. It's something a bit special. So before we can do some classification, like Charles explained, we need to do some training. So I'm not going to go through what is the step of the training. I'm just going to try to explain you the broad picture for this. So basically, you give the system, you give your machine learning computer like a bunch of classified picture, meaning like if we're talking about cat again, we gave them like 1,000 pictures of cat, and the computer by training will try to understand what is the common feature we find in this cat. So this feature will be very tiny feature, so it might be like just a color, just an age, just a texture. It might not make so much sense for us, but for the computer, these features are very valuable. This is what makes a cat in this case. So this computer will understand what all the features are common for the cat to make a detection of is there a cat on this picture or not. So very early on 2007, people in Stanford University in a computer vision lab, they understood that they needed a lot of data to do this. So they started this big project asking people from all around the world to classify more than 15 million images. So manually just labeling image like, oh, I see a cat on this picture, I see a cat in dog in this picture. So it's thanks to this kind of huge data sets that nowadays we can build very competitive object classifier for our convolutional neural network. So if we take an example, in this case, I'm going to give a cat. I'm going to use a mouse. So we say we have a mouse. We want to be sure this picture holds a mouse. So the convolutional neural networks already know what a mouse is made of. So in this case, we have a feature which is just an edge of the back of the mouse. So what the computer will try to do, it will try to see if this feature is present inside the picture. So what is it going to do? It's going to do some convolution. So it's going to take this filter, this very small patterns that we can find in a mouse, and it's going to do some basic mathematical computation on every item on every position of the array of the initial picture with the initial pixel value. The output of this will be the first hidden layer. So how this is working exactly? So we have here, we're just scanning through the whole picture, and we just reach the part where the back of the mouse is actually present. So we have our feature here. So we can see clearly here we have the edge that we're trying to detect. So pretty much like we did with the Sobel operator, we're just going to superpose both of these places, and we're going to multiply the number. So that means that if we have both a big value on either on the filter and on the initial pixel value, we're going to have a very high output number. In this case, we could say that the filter activated correctly. Now, if we're looking for a place where we don't have this shape, the output will be totally different, because the high number we can find here won't match the same numbers that we have here. And the output number will be very low in this case. So the filter won't be activated. So what we do with convolutional neural network, we repeat this process over and over and over again, different layer. And so every time you do a convolution, you kind of downsample the output of the initial pixel size. So every time it's getting bigger, and every time the feature you try to look inside is a bigger feature. Initially we started with an edge, maybe later we're going to go with a full nose or a full ear of a mouse. So this is what the computer does when you do many hidden layer. It tries to look for bigger and bigger edge. And what it does in the end, when it has like a whole bunch of output filters, some of them activated, some of them are not activated because it didn't detect a cat while it was in the mouse picture. What we have is just a fully connected layer. And the whole purpose of this layer is just to match all the filter was activated. And the label that this filter has, like if we were talking about a mouse, probably in the end we would have probably maybe 8 or 9 filters of the mouse activated and maybe just one of the cat activated. So the role of the fully connected layer is just to make a prediction and tells you that, oh, I believe that this picture is, I'm 90% sure that this picture holds the mouse and only 10% sure it holds the cat. So this is what the whole purpose of the fully connected layer. So now I'm going to explain one of the latest algorithms, one of the most efficient existing nowadays for object classification. It's called Yolo Algorithm. So YOLO stands for you only look once. So it's a kind of a smarter way to do some deep learning in a picture. So what the Yolo algorithm will do is pretty simple. We take, for instance, a simple picture. We try maybe to detect a cat, a dog, a bike, and maybe some things on the background. So what the Yolo algorithm will do, it will start doing some pre-processing technique before doing some classification. What it's going to do is going to divide this picture in different cells. And it's going to ask the computer, please, inside of each of these cells, can you try to detect object of it? I'm saying detect, not classify. Just try to draw bounding box around every object you can find inside this picture. So the output will be something like this. And what is good with a computer, the computer will also tell you how sure he is that this computer, that this bounding box holds something. So the next step will be just to discard all the bounding box that is not very sure that there is something like it. So the output will be something like this. We have less. We're gonna start to have less bounding box, and on every of these bounding box, the computer will start doing some basic image classification like we just previously did. So the computer won't have to look throughout the whole picture, trying to do some brute force detection on all the pixels of the picture. And the output of this will simply be just the classification that he will be 100%, he will be quite sure about. In this case, we don't have probably three match, which is bike, dog, and car. So I'm going to try to show you a live demo of this algorithm with my computer. So I use some implementation of the Yolo algorithm I could find on GitHub. We're kind of very busy inside this immersive course, so I didn't implement anything by myself. So this implementation uses a PyTorch machine learning library. It's trained on the Coco dataset, so it means like it can detect up to 80 different classes. So I brought some object here, and we're going to see if it's going to detect everything. So we have some, for instance, we have a bottle detects correctly. We have a cap. Okay. So unfortunately, my camera is not very good, and my computer doesn't do very well with graphics here. Okay. Okay, we can see them. Okay. We have a cup. Remote, no, cup. Pen. It has more than 80 different classes on this, so of course it's not perfect. Oh. Okay, I know this example wouldn't be that impressive. That's why I put a video. If you go on the Yolo website, the darknet website is a place where the guy who implemented this algorithm hosts all this algorithm. You can have this beautiful demo of how fast this algorithm can work. So this video was processed with a very normal computer using probably a high-end graphic card, and this is a live, this is a real-time processing. So the real force of this algorithm is just to detect a very fast object. It's much faster than previous model. This is the whole purpose of this one. Now, of course, it's not 100% accurate. As you can see, there is some mistake. But it's still very, very fast. So, to summarize, if you would like to start about computer vision, I would highly recommend to do some image processing technique like the one I explained, which is probably dozens of different image processing. Is pretty much the same thing that you can find in your Instagram filter. You can implement them by yourself. It's not that complicated. And I highly recommend you OpenCV to do this kind of test and try to learn a bit more of this. Of course, you have other library of MATLAB as well if you reach, of course. And of course, you have you can go a little bit further and trying to implement some object classification, like I just showed you, like the Yolo algorithm, using some of the machine learning algorithm available nowadays. So okay, so here are some of the reference I use for this talk. So as I told you, the darknet project is this guy PJ Reed is the one who came out with this Yolo ID algorithm. If you want to know a bit more about object classification, this guy has a very nice introduction of it. And of course, you have the imagenet.org. There's many different websites online who allows you to compete with each other to just try to design the best algorithm to do the best classification. And that's it.